Good morning, everybody. My name is David Banks, and this is my presentation for CIT 360 on handlers, threads, executors, and runables. So first, I'm going to kind of go over what these different things are. So a runnable is an interface that you need to initiate a thread to contain it. A thread has your state runnable, but doesn't necessarily need to access the runnable. So in essence, the runnable is I want to say almost a subset of a thread. And the reason you don't use a ton of threads is because it can really hog up your memory for your program. So you use runnables that can kind of separate the different threads and execute them without using as much overhead. I do have an example of a runnable and a test thread right here. If we run this file, you can see it says creating thread 1, starting thread 1, and creating thread 2, starting thread through, and it goes all the way through down 1, 2, 3, and 4, and then eventually it exits. So if we look at the back end of that code, we see that we've created the class thread. We've created a variable thread named T and a variable string named thread name. So we go down through here, we have our thread name right here, and our system output says creating the thread name. And the thread name is based on numbers 1 through 4, based on this program right here. So we keep on going down. We see we have a try catch statement that's set up here, and so we try the 1 through 4, right? And that's when it says, so it's creating first, then it runs, right? And that's why we have this method set up right here. And then the system outputs the thread name, then +1 until we reach 4. There is a catch statement for if that doesn't work for whatever reason, and it says this thread name, so 1 through 4 was interrupted, and then if the try statement works and there's no catch, then we have the system output of thread name plus exiting. So we come down here to our main class. Our main class simply just pulls that information from this class and creates thread 1, 2, 3, and 4. So that's a very basic thread program. A runnable is very similar to thread. That's why I named the variables pretty much the same. One of the main differences, however, is right here where it says implements runnable. If we go back over here, see this says extends thread. So the thread is created and is actually working or using a thread. This is implementing a runnable to execute a thread. And as I explained before, the reason you use runnables is because it takes up less memory, and you can do multiple threads within one runnable. So, but it's essentially the same code, which we can run real fast, just to give you an idea. You can see it's almost the exact same, or it is the exact same output as the other example, but this time it's implementing a runnable as opposed to extending a thread. So that's my two examples for that. The last two, the handler and the executor, the handler allows you to send a process message and runnable objects associated with threads message queue. Each handler instance is associated with a single thread, and that thread's message queue. For the example that I'm looking at least, let me pull that over so you can see. Make sure. Okay. So this is the handler. So there are two main uses for handler. One is to schedule messages and runables to be executed at some point in the future, and the second is to enqueue an action to be performed on a different thread than your own. So essentially, a handler does exactly what it sounds like. It handles the different threads and runables within your program. So, for instance, if I were to put a handler on here, it would essentially pull in the code for these two different programs, the runnable thread and the test thread, um, and it would decide programmatically when it needed to be executed, or it could be scheduled to run it in the future, or it could ensure, or it could queue an action to be performed on a different thread other than your own if you need that for any reason. So the last thing I need to go over is executors. So an object that executes submitted runnable tasks. This interface provides a way of decoupling task submission from the mechanics of how each task will be run, including details of thread use, scheduling, etc. An executor is normally used instead of explicitly creating threads. For example, rather than invoking a new thread for each set of tasks, you might use an executor and run those tasks 1, 2, 3, and on down. So I have another quick example for that as well. So an executor basically is a way to pull all of your threads together, much like the handler, and execute them in a sequential order, as opposed to having to create a handler and pull in all of those threads, or just create a separate thread or separate runnable for each task that you need to run. So that's all I have for now. I appreciate your time, and I know it might have been a little rough, but this is my initial understanding. So hopefully, as I research it more, I'll understand it better. Thanks. Have a good day.